Welcome everyone to this installment of our CADWorx webinar series. This webinar is a repeat webinar, somewhat a repeat. It's actually our second installment of a very popular webinar that we had exactly a month ago today in February, dealing with CADWorx FieldPipe and Leica CloudWorx. This presentation will be presented by John Brindley, who will demonstrate how easy it is to build intelligent models with laser scan data. Leica CloudWorx provides the tools to manipulate the point cloud data set inside AutoCAD, while CADWorx FieldPipe provides the tools to turn the point cloud into intelligent models. John Brindley and Joseph LaFranca will be presenting today. John Brindley is the sales manager for Plant Design Solutions here at COAID. He has a good background of piping and structural designer, using third-party applications all the way back since a long time ago in AutoCAD Release 10. He has real-world experience. He knows the market. He knows what you all deal with on a day-to-day basis. He's collaborated on many training manuals over the years, including the Pro Series, AutoPlant, and of course CADWorx. He's a principal author of the Plant Design White Paper, which was a comprehensive white paper comparing CADWorx to AutoPlant. Joseph LaFranca comes to us from Leica Geosystems. He is the Gulf Coast sales manager. I believe, is that right, Joe? The Gulf Coast sales manager for Leica?
Close enough.
Okay. During his 11-year tenure, he's been responsible for the sales and marketing of facilities, design, analysis, procurement, construction, operation, and maintenance software applications for the piping, process, power, and chemical manufacturing industries. As a central U.S. plant sales executive, sorry, Joe, for Leica, Joe has over 20 years of plant design experience. He has demonstrated successes in developing C-level visions and formulating strategies, as well as detailing implementation plans. He is an experienced communicator with audiences including customers, channel partners, suppliers, the investment community, employees. Joe has a bachelor's degree of science, mechanical engineering from Louisiana State University in Baton Rouge. And Joe resides here in the Houston area, and he's available for any subject matter of expertise in the high-definition scanning, construction, and power industries. Now I'm going to turn the time over to John Brindley. Before I do that, a couple of notes. We're recording this session. This recording will be placed on the blog for later review. If you want to come back in a day or two and review it, you can re-review it online. All of you are muted. There's a question box in your control panel on the webinar control panel. If you have any questions during the session, feel free to type those in. We plan on answering as many of those as we can at the end of the session. We'll also answer a few of them during the session if we feel that we can answer them right away. Most of them will probably be answered after the session, as many as we can. Now I'm going to turn the time over to John Brindley. To Joe LaFranca to show us this portion of the demonstration. And once again, thank you all for attending.
Thank you, Joe, for the introduction. Real quickly, a real quick agenda of what we're going to show today. Basically, four phases. I'm going to just do a little bit of a background with the software integration and basically just essentially how the data gets from the field into AutoCAD. So 5 or 6 video slides or slides rather to set the stage in the background and the product placement. Then I'm going to roll into a free viewer program that Leica has to be able to look at the site, we're actually going to take a quick little 3D tour of the area that John is going to then manipulate. So a couple of PowerPoint slides will look at the scene of the site, the plant in 3D through a free viewer. Then I'm going to turn it over to John. John will do the actual core software presentation, the integration with CADWorx, FieldPipe, and like CloudWorx. And then we'll sum it up and take questions and answer. So moving along, this is there's no quiz at the end of this. You don't have to remember this slide. Just wanting to show you how we go from laser scans into CADWorx and CloudWorx. Regardless of what scanner you use, the data plugs into the entire CADWorx professional suite. Actually, the data can subsequently travel into the entire COAID offering from piping layout all the way through to piping stress analysis and steel as well. Hopefully, if you guys are contracting for scanning services, you're using or intend to use one of our Leica service providers. These are independent contractors all around the country, or actually all around the world, who can provide laser scanning services. They do what's on the left side of the screen, and then hand over to you guys data that is ready to be manipulated in CADWorx without any type of intermediate process. Scanning, a little background about scanning. The technology wasn't invented for, but it was developed for the power and process industry because of all the challenges that retrofit projects are plagued with. Lack of as-built data, or worse, inaccurate as-built data. Complete inaccurate field data is always difficult and always expensive to collect, regardless of the age of a facility. There are scope changes, scope creep, change orders, all which make the data recently collected obsolete. Rust scheduled. The second and last one's a big one. We're using 3D techniques, but we're trying to apply techniques based on 2D take-back from the field. It's doable. It's what we've all done. It's not as elegant as an environment as it would be designing in 3D from your base data or your field data coming natively in 3D as well. So given all these challenges, we have to take risks. We have to weigh the odds. Sometimes it's not in our favor, and we end up with projects that can tend to be pushed behind schedule or delayed. So laser scanning was generated or developed to enable engineering and design, to simplify our life, to get better as-built data, more complete data. The data is discipline non-specific. Two guys in the field capturing data are capturing everyone's data. They're getting steel, they're getting equipment, they're getting HVAC, electrical, chain wheel operators on valves, on hand wheels, down to that finite of an element. And the intention is near zero defect. If it was laser scanned, chances are the design is going to be dead on. I say near zero because not everything can be scanned. Scanning can do a tremendous amount, but there are tight areas or spots where you still will have to do things conventional methods, tape drops, plumb bombs. It also enables us, because of a shorter cycle time from data collection. Scanning can do the work of, at a minimum, 8 to 12 survey crews in a facility trying to take data. It's a phenomenal upswing on the amount of data and the accuracy of data you can take back. And of course, we're directly integrating this data into your native CAD engine. So laser scanning was also developed to allow us, as EPCs or owner-operators, to beat our competition, to beat our competitor out at their cost, at their time or delivery schedule and quality. And it is done so by keeping internal design costs low, letting us win more bids, meet bonus criteria if possible. Sometimes that's the biggest profit we have on a project is just meeting the criteria to get the bonus, which may be sometimes the only payment in a job. And reduce the install cost, reduce the field fit because of design errors, and hopefully again achieve near zero defect projects. And then the improvement of asset management. This is huge for the owner-operators because it allows them to very, very elegantly and very accurately manage their asset. It's great for us in the EPC world because there's work to be done to go in and manage those assets or document those assets for regulatory information, for health, for safety, for maintenance, and training, and so on. And then like a FieldPipe FieldPro solution lets you actually as-built on site. You don't have to, but you can. So in the sake of making sure once our as-built is dead on, we can do it right there in the field without having to have a disconnect of having somebody take data in the field and another person or another entity or department translating it back in the office. So those three things, if the FieldPipe, if this whole solution we're presenting you today allows you to do it cheaper, to do it faster, and to do it at higher quality than your competition, any one of those things would give you a leg up on the competition, but having the 3 legs up on the competition or your competitor is huge, because hopefully we all keep quality as a baseline and don't suffer quality, but this technology gives us, gives your department, gives your organization the ability to vary the cost or vary the schedule a lot more efficiently and effectively than somebody who's using conventional methods. So everything I've said thus far, I've got it in one key visual. There's our little plant or pipe rack in the middle. And this is basically the value statement. Since we're all kind of 3D or visual people here, this just kind of shows it all in one thing. It's increasing safety. It's your environment is highly visual. What you see is what you get. It is by a magnitude more accurate than anything we can do manually taking in the field. It reduces the risk, both financial and physical. I'm going around in a counterclockwise circle here. A high level of detail. It's very, very it's unusual that you won't have enough detail in the point cloud to tell what you're looking at. And of course you can read on. It's going to decrease cost, decrease your cycle time. Scanning can take place in the field while production is in place, while the facility is in operation. Nothing has to shut down. So very versatile. And of course we get back to the one on the top, productivity. All these things speak to making us more productive. So in summary, CloudWorx offers laser precision accuracy, point and shoot component placement. Again, as you're taking points in the field or shooting points in the field, you can be placing them in CADWorx at the same time. Quicker and easier as-builts, improved safety. No one has to rappel, no fall protection, no climbing up around caustics or cryogenics, superheated or corrosives. Again, you're getting the steel equipment ducting and cable tray capabilities because it's the entire CADWorx professional seat embedded in the CADWorx CloudWorx offering. Collision checking, pipe specs, automatic ISOs, link to stress analysis and stress ISOs. Again, everything that the Co-8 solution can produce or provide for you can all be subsequently leveraged from the starting point, starting with the point cloud data. Technical specs for the offering, it's AutoCAD compatible Windows, Microsoft Windows XP Pro, or Windows Vista Ultimate as your platform. So it's safe to say it's ready for everyone's platform. If you're out there and you're using AutoCAD, if you're using CADWorx and AutoCAD, you are ready to take laser scanning data probably in about 40 minutes, maybe an hour and 40 minutes time. You'll be up and running with all of the functionality of CloudWorx in your native environment. So having said that, I'm going to now jump into or move over into TrueView to just a couple of moments to show you where the data came from. What we're looking at here is a site plan of an area in a refinery near a tank farm, and over here there's a pump station. The line that John is going to model up and interface with is a line coming out right off this vessel on a 45. I'm going to drill down into this free view or this TrueView product from Leica to be able to witness or look at the line we're going to be manipulating. It's this 16-inch line right here with this gate valve and this connection running off the bottom. I'm going to zoom around or pan around. I do it kind of slowly because I don't know the response time of the video. And over here is where that line comes out of the big tank of the vessel on a 45. The beauty of this of the TrueView is if laser scanning providers are scanning your site, they can quite easily, quite simply provide you back this type of interface for getting your bearings if you hadn't had the luxury of being in the field. This is not a photo. This is just the point cloud with no type of photo overlay. That's why my sky is black. There is nothing back there. This is basically an iteration of what is in the CAD model, of the point cloud model. To get a little closer look at the line over here that we're going to start with, and then over here I'm just going to jump to another perspective, another location from where the laser scanner was shot, and then I'll zoom back over here so we can look quite closely at this 16-inch, 150-pound line. In some cases, this data is tight enough to actually be able to read the stampings or the boilerplates on these valves. And again, I'll turn back around and look up. All right, and I don't know if this is smooth. Joe, is this a smooth? Are you seeing this?
It's behind, Joe.
Okay.
Right now we're looking at the vessel with the line going into the vessel.
Or is it panning smoothly or is it jerking?
Well, it's not jerking; it's just delayed.
Oh,
Okay.
in this case, delayed. Thanks.
Yeah,
then I'll keep it. Okay, so that's about it. This is the other end of that line that John's going to model. This is it coming around the control boxes. And having said that, I'm going to now turn it over to John. John is in CloudWorx, where in CloudWorx he has clipped out a portion of this model, clipped it out in all directions so that he's looking just at this line to simplify any CAD operator's job or task, so that you're not selecting things on top of things. Obviously, it's a great idea. And the slicing and dicing that you won't see John apply, but that is currently applied when he starts, is a function of the software. They're just routines that we are invoking AutoCAD to do so. You can also do your own flipping planes if you're familiar with that as well. But it is an integrated algorithm inside the product offering to very simply and elegantly slice it down, clip it down, or use a limit box to limit what you're looking at so that you can reveal just pipe along a particular elevation or features in plan or in section. And with that, thanks. I'll be back in a moment with Mike Harvey when we do the question and answer. Mike's with us. He's my partner, my colleague at Leica, one of our technical engineers. He's going to be online at the end so that that you guys can't stump the chump with questions. John, I'm going to turn it over to you now.
All right, thank you, Joe. Appreciate it. As Joe mentioned, I'm already in a CADWorx FieldPipe session with CloudWorx running, so I'm using CloudWorx as the tool to view and manipulate the point cloud data. So we're really looking at two solutions here. We're looking at CADWorx FieldPipe and CloudWorx, and I'll go into more detail about those at the end of the presentation. Right now I'm going to crop out this model a little bit more and actually using the limit box. Joe had already set up a limit box for me that crops out the major portion of the piping I'm going to work with. So we're going to as-built model this run of piping here using some tools, a combination of tools between CloudWorx and CADWorx FieldPipe. So the first thing I want to do actually is use a tool in CloudWorx to fit pipes to the cloud. And I've got a number of options here. I'm going to use the basic, just the pick point option, which tends to be the fastest and easiest. Sometimes, depending on the density of your point cloud, you might want to use a fence option so you improve the accuracy. But on this model, the pick point method seems to work pretty well on this large line. I'm going to pick a point on each of these three segments of pipe, and what you'll notice is that CloudWorx went in and looked at that point cloud and determined the center line location of that cylinder and the diameter. So I'm dealing with 16-inch pipe here. So now in CADWorx FieldPipe, it's a spec-driven application, of course, so we're going to set our size to that pipe size, 16 inches, and set our spec. I've gone in here already and done a measurement, but I could do a simple distance in AutoCAD across one of these flanges to get my rating. And this is a 150-pound line. Now we're going to use a tool in CADWorx FieldPipe. First, we're going to set a line number, and then we're going to synchronize that line number with the FieldPipe function, and then we're going to use the CloudWorx option here to connect these pipe center lines. So there's a couple of options here. We can find the pipe diameter just by clicking on one of these lines and have it set those settings here. Or in this case, I'm already set to that size, so I'm going to use the connect center line method to pick these 3 lines. And the program says that our connection exceeds a tolerance that we've preset as 0.2 inches. In other words, this is real world. These lines don't precisely line up, and it asks if we want to connect the pipe anyway. Well, yes, we do. It's already there, and it's connected, so we're going to pipe it up. And one of the advantages of CADWorx FieldPipe is when we say yes to this dialog, it's going to place butt weld pipe and elbows with long radius elbows in this case. And you'll notice that it pipes it all up and connects it correctly, even though these things weren't perfectly square and perfectly aligned, as they rarely are in the real world. All right, now we're going to come in and place some inline components here. So I'm going to start over here. We'll start with this check valve maybe. So I'm going to go to my 3D input dialog that's part of CADWorx FieldPipe. And in this dialog, I can select the inline components I want to place. And I can actually have the system place multiple components at one time, which is kind of nice. So I'm going to start with a flange check valve and the 2 connectors, which would be raised face weld neck flanges in this case. And then I'm going to use the insert object manual measurement method. This other icon to the left is a tool that's used when CADWorx FieldPipe is connected to a Leica total station, a TPS total station in the field, where you can actually use the total station to shoot the data, the point data where you want to insert objects. But in this case, we've got the point cloud to do that with, so we're going to use the insert object manual. It asks me to select the pipe that I want to insert the objects on, so I'm just going to cross through that pipe. And then it asks for an insertion point, which in this case is the back edge of a flange. I'm going to zoom in here a little bit and just use a node O-snap to get one of the points that represents the back edge of that flange. And you notice it went ahead and put in my flange, my check valve, my gaskets, and the mating flange all at one time. Now, this is real world. Sometimes these points go in properly. Sometimes, you might have to pick a couple of times, but it actually is really easy to go back and affect any changes that you need to make in the model. So I'm going to now put in this flanged gate valve with 2 flanges on that same pipe. And then again, it asked me for an insertion point, so I'm going to pick a point on this flange. And I didn't put my gate valve in. So again, this will show you how easy it is. Good old AutoCAD undo. And let's try that again. So I'm going to cross this pipe. And there's our flanged gate valve. Okay. Likewise, I could do the same with these breakout flanges right here. So I just turned off my gate valve, and now I'm going to pick and place my breakout flanges. Now you notice one thing here, as a CADWorx, experienced CADWorx operator, I noticed that this pipe got broken back and connected to the flange, but this pipe did not. And that, of course, has to do with the fact that this is not 100% orthogonal and slightly skewed. One of the beauties of CADWorx is I can grab that grip for that pipe and just stretch it back and mate it up to that flange. So the repairs are very easy and simple to make. Now let's move over here to this section where we've got a T branching off and another gate valve and a flange with a blind fledge on this end of the pipe. Now, there's not a lot of point data here for me to define the center line of that pipe. So, and I'm basically almost fitting makeup off of this. So I'm going to use some other CADWorx Plant Professional tools, which are all included in CADWorx FieldPipe. I'm going to set my UCS first by this piece of pipe, and then I'm just going to use regular AutoCAD stretch by grabbing this grip and stretching this pipe back out of my way, because I can tell that this T is fitting makeup off of this elbow. And my UCS is set to this elbow and pipe, so I'm just going to come over to my CADWorx spec view window and select a straight T and insert that at the end point of this elbow, branch going this direction, and then all I have to do is connect my pipe back up to that T. So all the core functionality that exists in CADWorx Plant Professional, it makes it easy to modify and change the model very quickly using basic AutoCAD commands and functions. That's all in here. Now I want to set my UCS to this branch side of this T, and I'm just going to show another feature here in CADWorx FieldPipe that allows me to just take and draw a line down the center line of that run of pipe. And then I'm going to use a tool that's included with FieldPipe to copy the center line from this pipe run over to this pipe run. So now that's an intelligent CADWorx FieldPipe pipe, and all I have to do is select this pipe utility here to actually show that pipe. All right. Now let me zoom in here a little bit. We'll put this flange gate valve in and our blind flange and mating flange here. Let me refresh my point cloud so I can see that it's a little denser here. And let's go back and check off the checkbox for the gate valve. So we'll insert the gate valve with both flanges on this line. And the insertion point, let me zoom in a little bit. I'm going to grab one of these points, and it's going to go that direction. So there's my flange gate valve there. And of course, I'm going to put my mating flange or my weld neck flange here in my blind flange. So I'm going to change this connector to a blind flange connection. And then put that on this pipe. And again, I'll grab a point here. And there's my mating flange. Now again, this pipe I need to stretch back to make sure it's connected. This piece of pipe was the overage pipe that I extended that line, so I'll just get rid of it. And I'm done at that point. So now we're ready to reap all the downstream benefits of modeling a fully intelligent 3D model. Let me go ahead and turn off, let's see. Well, that's all right. I don't need to do that. I'm going to go ahead and go into an isometric viewpoint here and go to a rendered mode so you can see the piping and components that I've placed in this model. All right. CADWorx also has tools for placing operators from the spec, so if we wanted to put these hand wheels, etc., in, we could do that as well. And then, of course, a couple of the final things we're after here. First of all, we want to generate an isometric of this. So I'm going to run isogen, which is included with CADWorx FieldPipe. And I'll just use that isometric style and select all these components. Oops, got a little disconnect there. All right, not sure what I've done here. Maybe an issue with my isogen. Let me try this real quick. Yeah, it's an isogen issue. So we're going to save this drawing and come back in. I think I've got a problem or a setting in my isogen. I'll just save this to my desktop. Call it Cloud 1. And fire back up real quick. I could bring the point cloud back in, but I'm not going to take the time to do that at this point. Let's go ahead and go to isogen. And there's our isometric. Now, obviously, nothing in this model is orthogonal. So the ISO looks a little skewed, which it is, of course. I've got my north arrow up and to the left. And so here's my actual isometric based on the real-world model of that piping. Okay. Another downstream automation capability we get, as Joe mentioned, this will interface with all the CoA products, so I can do a Caesar 2 system out from here. I'll call it Cloud 1, that's fine. Select these components. Let the systems provide the node numbering for me. Okay. That's fine. And it's created my Caesar 2 input file. Which is where? Caesar 2. That was on my desktop, Cloud 1. Oh, sorry. I've got a beta version of 5.2 on here, so I've had a little error with my Caesar 2. Anyway, my Caesar 5.1 is not installed, so that's what I did. I didn't output that to 5.2 format. Yeah, 5.1. All right. Anyway, the bidirectional interface that's been in place for 10 or 12 years now between CADWorx and Caesar 2 is also in effect with this 3D model. All right, that's pretty much what I had as far as the modeling portion. I want to now take you guys through what's involved and what's included or required for this particular offering. So the combination of CADWorx FieldPipe and Leica CloudWorx consists really of two required components, and each comes in two different flavors, if you will. First is CADWorx FieldPipe, which is available either with a TPS option for connection to a Leica total station, so we can actually collect point data in the field using a Leica total station and as-built modeling directly in the field, or in the case of probably many of you that may be using laser scanners for point cloud collection, where you're actually going to be either modeling in the field or post-processing in the office using a point cloud, then you have the option of buying CADWorx FieldPipe without the TPS option, so it won't connect to a total station, but it will have all the same functionality manipulating the point cloud and as-built modeling as you've seen here. And then on the CloudWorx side, Leica has developed a special version of CloudWorx called CloudWorx Basic for us that can be purchased through CoA. You see the pricing listed there, US $15,000 for the CADWorx FieldPipe with TPS, $11,500 for FieldPipe without the TPS option. And then the other component you've got to have with either one of those FieldPipe options is either CloudWorx Basic from CoA. Functionally, the pick points are a little bit different in CloudWorx Basic than what you saw today. I was showing you on CloudWorx Professional, but the workflow process is basically the same, except when you put pipe and elbows in, you're just really picking 2 points on the point cloud for each run of pipe, instead of selecting the line that went in from the 1-point pick of CloudWorx Professional. And then, of course, CloudWorx Professional. Many of you, if you've already got a laser scanner, if you've got a Leica laser scanner, you're probably already running the CloudWorx Professional. You have to be running the latest version for this interface with CADWorx FieldPipe. CADWorx FieldPipe, again, it consists of two complete applications. It consists of a full license of CADWorx Plant Professional, which is 2D and 3D piping, structural, HVAC cable tray equipment, a parametric equipment modeler that has bidirectional capabilities with our PV Elite pressure vessel analysis software, automatic ISOs via ISOGEN, CADWorx Design Review, which is a design review walkthrough tool for doing your walkthrough design review, built-in clash detection in the modeling environment, insulation, TopWorx, analysis interfaces, and much, much more. And then it also consists of a full license of Leica Field Pro, which is Leica's the TPS interface software for field capturing of AEC data. Okay. Then CloudWorx, of course, also comes in two formats: the CloudWorx Professional, which you've seen here today, complete tool set for Leica point cloud manipulation and modeling. A lot of tools that we haven't shown and discussed here, of course, in that application. And then CloudWorx Basic, which is a subset of CloudWorx Professional, specifically designed to interface with CADWorx FieldPipe for modeling pipe and inline piping components. All right? And that's it. We really appreciate your attendance. I guess we'll open the floor to questions, Joe.
Yes, yes.
I'll turn it over to you.
Yes, and if you have any questions, go ahead and type them in now in the question box on your control panel. We have one question right now. Is the ambient noise in the point cloud data automatically removed by the software? Let me open up for Joe or Michael. Did you guys hear that?
You're talking about some of the spray off of the point cloud. Is that the question?
It just says, is the ambient noise in the point cloud data automatically removed by the software? Not sure.
Yeah, so I'm kind of guessing that it might be some of the spray. So the algorithm uses a best fit cylinder, so it takes an average of all the points, and it's smart enough to know to ignore some of those other the extraneous points.
Okay. That's the only question we have so far. If there's any more questions, quickly type them in and we'll answer them for you as users. That might be all the questions we have for today. Everybody's pros at this right now. So that's good. That's really good. Well, I hope all of you have enjoyed this presentation. The presentation today, again, this presentation has been recorded, and you can get it on the CADWorx webinar blog. That blog is, let me show you where that's at real quick, just so you have that. Let's go screen too clean. That blog is at coa.typepad.com/CADWorx, and it'll be under the past webinars for you. Another thing I want to mention is our upcoming user conference, which is coming up in September 28th through the 30th, and you can sign up for that on www.coauserconference.com. And early bird registration ends July 1st. So sign up now as soon as you can. Again, I want to thank Joseph LaFranca and John Brindley and also Michael for joining us today and presenting the this webinar presentation. I hope all of you got something out of this presentation, and I want to thank all of you for your attendance today and taking the time. Thank you very much. Bye.